Okay, I've got some complicated looking formulas here. I'm going to explain what each and every letter stands for. I've got the description here, but I'm going to explain what these formulas do. Right, but first, if you just look at the top right hand corner of your screen, let me just expand that. Right here, I've got a cannon. I can choose its angle, I can choose the speed. Right, the higher the speed, the faster it will go to begin with. That's the angle, right there. Right there. Okay, it starts at 25 degrees, I can't get it to 0 degrees, but then you can go up to 90 degrees straight up. But if I fire straight up, it's most likely going to come back and end up damaging me. Right. My target there, as you can see, is 22.5 meters away. My job is to hit that target first time round, and I'm going to use a formula to get that right the first time round. But remember, here I'm not taking air resistance, wind, or anything else into consideration. What I will do is set this cannon to 15 meters per second. Right, I'm going to fix that, but the only thing I'm going to move now is the angle. I'm going to decide what the angle is. So remember, the speed, the initial velocity is 15, as you can see there. Let's have a look. Just move that out of the way. Right. If you look at this formula here, R stands for range, how far the ball travels along the x-axis. And remember, I want it to travel at 22.4 meters. So I would like R to be 22.5 meters. That's my target. That's fixed. I can't change it. So that's R. U, the initial velocity, remember I've set it as 15 meters per second. That's speed at which the cannonball will fire. I've set that as 15 meters per second. So that's U. Right, that's U there, and that there is pronounced theta. That's the angle on which I'm going to fire. That I don't know. I'll leave it as a question mark. G is acceleration due to gravity. That is set as 9.81. That's fixed. Obviously that will vary depending on very slightly depending on where you are on Earth. So if you're on Mount Everest, obviously the furthest point away from the center of the Earth, that will decrease, that value will decrease ever so slightly. Right, my job is to work at theta. So starting off with the formula, I'm copying that, sine 2 theta, 2 times theta. Remember, that's the angle, and that's G. Right, what I need to do is work out that 2 theta. Let's substitute some numbers in first. Let's see what happens. R is 22.5. Right, let's do it. U is 15. 15 squared. Sine 2 theta. I'm going to find out what this is. And G is 9.81. Right, let's simplify that a little bit. 22.5 is just 22.5. Can't change that yet. 15 squared is 225. That's divided by 9.81. So all of this, let's do it in green. I've just worked out as 22.93. Okay, 22.93. I'll just round it, 22.94 then. And that's just sine theta, sine 2 theta rather. Remember, that's an invisible time sign here. Get rid of the to get rid of times, you need to divide. Divide by 22.94. What have you done on this side? Do on the other side. See what happens now. 22.5 divided by that number there. 0.98. Right, these cancel. You're left with sine 2 theta. Right, from trigonometry, you'll know to get this out, you need to do shift sin. Shift sin 0.98. So 2 theta, that 2 theta is equal to 78.52. So 2 times something to give you 78.52. Just divide by 2 then. Divide by 2. Theta is equal to 39.26 degrees. So here we go then. I'll just write it to 39 degrees. Right, fire. There, precisely right. Right, this formula is the rearranged version of this. This topic is called rearranging the formula, or making subject to the formula. And I've made a video on this a while back, but anyway, here's the formula. What I can do now is use this formula to help me get the target every single time. So if you just watch the screen. Let's see if I can move that over here. Right then. This time, let's get rid of that. Set the target. I don't know, just making this up now. That's as far as I can go. Right, 30.8. I've made R equal to 30.8. Let's change the speed, the initial velocity. I'll make that 20. U is equal to 20. And that's meters per second. I'm going to work out the angle now. So this is what I will type in the calculator. R is 30.8. G, this stays fixed. That's the acceleration due to gravity on Earth. U is 20 squared, all divided by 2. That should give me the angle. Let's try this. That shifts in. Squared. Right. I can treat that as divide by 2. Divide everything by 2. 24.5. Oh, shall I use 24 or 25? Let's have a go. Let's try this now. 24. Try 24. I can't go in between 24 and 25. I'll keep it as 25 then, see what happens. I'll probably just go a little bit further. We'll see. Right, fire. Right, as expected, it's gone. That's the target there in the middle. It's gone a little bit further, as I've just said. Now you're probably wondering what these do. That's time, and you guessed it. It's the time of flight. From the moment it's fired to the moment it lands, that's the time taken. And the other values, initial velocity, acceleration due to gravity, theta, the angle, you know all this. And that one there is the height. It's the maximum height. So when it travels like that, that's the maximum height. And all the other variables you know. So let's work at the time of flight. 2 times, what was the initial velocity we chose? The initial velocity, let's just have a quick look, was 20 meters per second. Sine theta, the angle, what do we choose? 25 degrees, 9.81. Right, let's work this out. According to the formula, the time, t, time of flight, is 1.72 seconds. That's how long it took to get from the cannon to the surface. And the maximum height, well, initial velocity is 20, so we have 20 squared times sine 25 squared over 2 times gravity, acceleration due to gravity. Let's work this out. Right, for the sine 25, put it in brackets because I'm going to square it. That's sine 25. Look, 2 open brackets, 2 closed brackets. That's how this calculator deals with it. We need to square sine 25. 3.64. The maximum height reached was 3.64 meters. Let's test this out. Let's see if we can find this out. Starting here, that's time. Range is the distance. Okay, we know that. That's 30.8. Height, that's what we're after. Right, time. Let's go for time first. So from here to here, I don't know if you can see on the screen. You can just about see it. The time taken is 1.72. See that? 1.72. Right, that's what I calculated, 1.72. And the height, that's the maximum height reached, is here at that point there. Maximum height 3.64 there, 3.64 is exactly what I calculated. If I just show you, there, 3.64 meters.